Assalamu alaikum and hi, my dear students. How are you? Hope you will be fine and okay. By the time you are watching this video, you will be in the best of health, wealth, and happiness. In my last lecture, I've discussed with you the MCQs and the question answer in the exercise and the numerical part. The numerical part was remaining. In my today lecture, I will focus on the numerical part of the chapter, and this is the last part of the chapter. But before going to start numericals, I would like to tell you about the problem solving techniques, right? That is very important uh, because that as my experience is concerned, then most of the students feel difficulty in solving the numericals or the physics problem, the real day lab problem. For example, it is very easy to memorize the F is equal to ma, but it is very difficult to apply F is equal to ma into our real day life situation, right? This is why, because students mostly avoid this part of the physics, and this is extremely important, right? So I want to explain it to you that how we can solve the given problem. So I would like to start from the problem solving strategy first. So let us start with the name of Allah Almighty. Bismillah ar-Rahman ar-Rahim. There are few important steps which will help us develop our skills and techniques to solve a particular numerical, and that I would like to write it or to call it as the problem solving techniques. So problems solving techniques, problem solving strategy is the best word or strategy. It is I would like to explain to you. So this is what inshallah we will be doing in our this lecture, right? The first most important point here is the point not to be in any panic. That will be our first step, right? That is number one. Don't panic. Question is why? I heard this from the students that I understand the material, I just can't do the problem. Then that is very troubling. If this is true of you as a physics students, then maybe you need to develop your problem skills first, right? You should not go into panic, rather, and there is it is not just like a kind of monster which you cannot deal. It is not that you are being caught between the devil and the deep blue sea. This is very easy. It's only require your determination, your devotion, and your dedication, right? Once you practice it, then you will never be afraid of this thing. So you should not panic. That will be our first step, right? The second important point here is the point where is the number two. Read carefully. Read carefully. That is our first second point. If you see, I wrote in the start that making a small mistake in the reading of a problem can cause a very large change or a very large mistake in its solution. So, if you make a small mistake in the reading of any particular problem, then you will definitely make a very large mistake in its solution. So, you must carefully read the problem. If you do not understand the logic, while reading it for the first time, read it twice or even more so that you can get good grip on the numerical or on the problem. So that is very important. This will make us identify the physical principles involved, right? So that is important for the identification of what? For the identification of, let me write, the identification. Yeah, this is simply to identify the physical principles. The physical principles that are involved. So that is important that we must identify the the physical principles, that through which principle we can solve the given thing. The second thing is your knowns and unknowns. That is very important too. That the third step, you must know your knowns and unknowns. That is what we can say, the given and your required, right? And you need to label them. So if you are capable of finding your knowns and unknown, then that will help a lot towards the solution of a problem. Now, one thing I would like to tell you that in the known and unknown, there are two kinds of thing you should focus on. In the known, sometime your known, which I want to label this known, your these knowns might be sometime clearly, they will be clearly visible, and sometime they will be hidden. For example, it could be a constant which is not given. For example, the universal gravitational constant are usually not given. The acceleration due to gravity, it is not mentioned in the numerical. Most often you have seen this in the previous chapter, your teacher might have told you about that. So that is the problem where you must take care of, that you first write all the visible and the invisible, right? The given in your numerical, right? And you must label them. The fourth important point is the fourth important point, the fourth point is to construct a mental image of your problem, and that is what a careful sketch or a diagram you may have, like a sketch I would write, that you must construct a simple or a rough sketch of your problem. Why? Because sometimes your problem may require a force diagram to explain certain numericals. It is not necessary that diagram will always be needed, right? Graphical, sometime a graph might be given, right? So you should construct a mental sketch, right? And that is important. Once you get the mental image of certain numerical or certain problem, then you will be capable of using it further, right? That will help you a lot. Now, these steps are not supposed to be written while solving every problem. You must only understand these steps, and then you apply it only. So that will be the next one. So you should construct a sketch. The next important point is The next important point is the unit consistency checking. That is fifth point. The fifth point. Units consistency checking. The unit consistency checking, you know that you might have the unit, the MKS system, you must have the FPS system of measurement, the CGS system of measurement. So you need to know that which physical quantity is mentioned in which unit. Throughout this book, we usually use the MKS system. So all the unit must be in the MKS system only. So if, for example, if a time is given in minutes, you need to change it into second. If a length is given in centimeter or millimeter or a kilometer, then we need to express it into a meter, right? So unit consistency checking is very important. If you do not follow this rule, definitely you will come across a wrong answer. So that is very important that you follow the rules of the unit consistency checking. All the unit must be MKS. MKS system is usually System International. FPS is for pounds system. That is a British engineering system. CGS are the imperial system of measurement, usually followed in the United States of America. FPS in the uh, British engineering system, and in case is the System International. And definitely you would like to be in the System International, right? So that is the MKS system. The second part to this is the use of what? The use of the correct formula. I think, did I told you about the unknown? Yes, that is your required. The next is the fifth. The fifth point is the use of correct formula or proper formula. Use of the correct formula. That, that is, there are many approaches towards the solution of a problem. So the easiest approach first, this will help you save your time, right? Because you know that in the exam time is extremely important. Even a second counts there. And let me tell you one important thing, that whenever you are in the examination, you must remember few important things to know. And those few important things to know, the first thing which matter is your concept, right? That if you have a concept, then exam will not be a big deal for you. So concept is very important, that you should have the concept of your subject and the numerical are the things. The second important point here is your memory. You must have a very strong memory, right? Because for example, sometimes you will be capable to understand the logic of the given problem or the given numerical, but you wouldn't be remembering that formula properly, and you will be thinking whether it is m is equal to gr square by capital G, or whether it is gr square by small g, and then you stuck there. So memory must be strong enough, right? And and how this will come? This will come through practice only. That the more you practice, the more you will be better to remember the problem. The formula. The third point is the speed. Speed will help you win the race of life. Sometimes the students know a lot of things, but they cannot finish on time. Why? Because they are lacking practice, because they are lacking speed. The more you practice, the more you will gain speed with the passage of time. So that is a very really important. point. So that is how you will be able to cope with your paper. So I was talking, let us come to the point. I was talking about the use of the correct formula. So I told you that there might be sometime many approaches. For example, our problem can be solved by using this second equation of motion or the third equation of motion. Sometime a problem can be solved by using the combination of first and second, but they can easily be solved by using the third equation of motion directly. Sometime all these three equations are used in solving a numerical, but the fourth equation of motion is very easy and all-time favorite to solve the problems very quickly. So that is the most important thing which you should keep in your mind. So the use of the correct formula. Second, that the next one is how the next one is the use of what? The next one is the use of calculator, and that is the sixth point. The calculator in your calculations. Now you know that even now the board allows you the use of the electronic gadget, not all the electronic gadget, but the calculator, right, to solve your problems. That is important, that now which kind of calculator you must choose, right? First of all, usually when I just say the students do it with your calculator, they use their smartphone are not the best option. Okay, so even if you are at home and you are solving, please use calculator. This will inculcate the habit of you in using the calculator, particularly in the exam, because the mostly the smartphone calculators are not that much convenient and easy to handle, right? Therefore the you must use the calculator, and in the calculator you must have two-line display calculator like this one, anyone the case or any. It is, I'm not just telling you that you should buy these, but these might be the options, right? The best calculator you have, and the better you will then perform in your exam. So two-line display calculator will be the best one, right? Like this is your single and this is two-line display calculator. So that is another important point. The next important point is that is the seventh point, I think. Yes, the seventh point. And the seventh point is no, point seven. It is the use of the seventh point. It is the check your solution. Checking your solution. And I would like to focus on this more because it is important. It is nothing, checking your solution, yeah, checking your answer, right at the final, that what final answer you are getting, and then you just give 2 or 3 minutes that whether it is the correct or the right answer which you want. So that must be checked. It is not that in the exam you do not have the book to match the answer. I'm not talking that way, right? I'm talking in a general way. You use your common sense about how the real world works, right? That is the important thing. That is the result reasonable and within your experience. For example, I would like to tell you that cars do not travel down the highway at a speed of 300 miles per hour. This is not our common observation. So if your speed comes to be within the, for a car to be within the range of what? To be in the range of the 300 kilometer per hour. So that is not the day-to-day experience. Car never travel within with this speed. So that is another important point. Second, for example, the if at the end, if you are calculating the velocity in the unit comes out to be meter per second square. So velocities are not measured in meter per second. Velocity is measured in meter per second. So definitely there will be some mistakes in your solution. So you should go back and check. Or for example, if a time comes out to be negative, then time is scalar quantity. It cannot be negative. Time is always positive. Yeah, for example, if you are calculating the mass of the moon and the mass of the moon came out to be bigger than the mass of the earth, so that is not a reasonable solution. So checking your solution is the most important point. So these are the few steps which you need to solve a particular problem. So that is the most important point. Now I just want to go back to the point fifth, which is very important. In the point fifth, I talked to you about the use of the correct formula, that how we can use a correct formula. You know that there is if you see on the screen, as I wrote label on the screen, there you see formula in its standard form and that solve for. Look, this is the formula for the universal law of gravitation, and this is in what? And this is in the this is in the standard form. Now the substandard form, for example, you can solve for d like this, you can solve for m like this, and you can solve for m2 like this. When m1 is given, you can solve for m1 when you m2, and the rest of the physical quantities are given. So better to memorize this formula. Okay, you should not always look towards the formula directly to solve a given problem. You should practice and you should learn. Similarly, for example, this formula is the most important formula, where you need to calculate what? You need to calculate the mass of the planet if the value of the g on the planet or the radius of the planet is known. This g gravitational constant, and this is always known to us. As you see at the mass of the earth, sometime if it comes, you must remember all these variables by heart, right? With the formula or the expression, and you need more practice for these things. Clear? So if you know the standard formula and the substandard formula directly, then they will help you in the MCQs. For example, if there is a small numerical in your MCQs, and if you know the substandard formulas, then you can quickly and directly use it while avoiding the solving for the given expression. So that is these are the most important point which you should know, that a formula and the substandard of the formula must be known to you. Okay, you must remember this. Right now for the practice, let I should solve some of the numericals to you. For example, look, we will be applying those principles right right now here. Look, for example, look at this numerical. The first numerical: find the gravitational force of attraction between two spheres, each of mass 1000 kilogram. The distance between the center of the sphere is 0.5 meter. So if you look into this problem, the solution, then in the data, you must first find out your givens, that what are your given. The givens are in this problem, you just see, look, find the gravitational force of attraction between two spheres, each of mass 1000 kilogram. So here you see that masses are given, right? And the masses m1 equals m2 equals m equal 1000 kilograms. So masses are given, both the masses are given. The distance between the center, distance between the center, between, I will not write the between, you the between the center of the two bodies, and this d, it is equal to, this distance is equal to 0.5 meter. Now these are the visible part of the physical quantities known to us. Some physical quantities or physical constants are not given directly here. You see, there is no gravitational constant, value of the gravitational constant. So I will write it myself. Gravitational constant. This is not given there. G 6.67 into 10 raised to the power minus 11 Newton meter square per kg square. It is not given. That is the gravitational constant. They want now what is required from us. Required is what? Required is the force, the gravitational force between them. This is required. So definitely you have what? Which formula you have? This the formula in this in our solution, right? Which formula will be used? A's from the you will be writing A's from the law of universal gravitation. F is equal to what? G m1 m2 by d square. Okay, so you just see, look, you will not just go this way but in steps, right? Is due to limited space, I'll be writing here. You see, look, which formula will be used for this? Directly we can use this formula. So this is F will be equal to what? 6.67 into 10 raised to the power minus 11 Newton meter square per kg square into 1000 kg into 1000 kg kilogram divided by d square, so 0.5 half meter whole square. And use your calculator, write your answer, and your answer would come in the Newton. Okay, so that is what the proper unit. Now you need to either to remember this thing, or if you don't remember, then you need to simplify this thing. So why to simplify? You just see, look, Newton meter square will get cancelled, kilogram square and this kilogram, so these will get cancelled with each other. So the answer will be in the Newton. Now you know this was a very simple problem. Even this problem, in this problem we do not need to draw any sketch, right? There was no complication, so I did not do that. Now, if you just see, look at the next numerical, the gravitational force between two identical lead square kept at 1 meter apart is 0.006667 Newton. So in this numerical, if you see, the gravitational force is given. So our given here, the gravitational force, that force F, this force equals how much? It is equal to 0.06673 Newton. And the superior masses, the find the masses, find their masses, we will be finding the masses. Okay, the superiors, the distance between their centers, distance is given, this distance d, it is equal 1 meter, right? And the value of the gravitational constants, as I told you, this gravitational constant, this must be written, and it is 6.673 into 10 raised to the power minus 11 Newton meter square per kg square, like this. Okay, so what is required from us? Required. In the required portion, we need to find the masses. Since the masses are identical, so that is m1 equals m2 is equal m. This is required. Now if you just see, if you remember, you will just write simply from the Newton law of gravitation, and then instantly you will what? You will now just go and pick the right formula, and that is this one. This formula, you just see, look at this formula. This formula will be used. We will be using this one, the substandard form of the formula, right? So A is from the Newton law of gravitation directly. If you remember this formula directly, then okay, no issue. So A is this formula, M is equal to what? M is equal to F by D, F by, sorry, F by G under the root into what? Into D, right? Now I got how I got on this formula. This is, look, you just see, look, this is very easy. Look at the Newton law of gravitation, F like this one. So you see F is equal to G, M1, M2. So they are the same. So M square and D square, there is already a D square. So F D square, it will go there, it will come here, and you have the M square. So if you take the square root, this in the next, for example, so it will just come out to be FG square root. And if you take the square root of the D, it will be D. So this is how I simplify the formula for you. So if you remember, you will be able to quickly solve the given numerical. Now another important point, class, which I want to tell you is the formula sheet you see. This is, I do not recommend this for you all the time in front of you. You need to memorize it, okay? Because if it is in front of you, you can easily solve. But once when you sit in the examination hall, it will be then very difficult for you. Look, see, find the acceleration due to gravity on the surface of the Mars. The mass of the Mars is this one. So again, if you just see, look, the given in this, what are the given? The given to you, the acceleration due to gravity on the surface of the Mars, we are going to find. So the mass, m. The mass of the Mars, it is given 6.42 into 10 raised to the power 23 kilogram. Okay, that is, and the radius is 3.77. That is, oh my God, this is where, from where I have made a mistake. While, okay, class, I do not now know because as I don't have the book in front of me. Let me check in the book, but here is the book. Oh, I don't have the book. So it could be what, this could be any value there, and that value will be, I think, in meter or in kilometer. I will be writing in a kilometer. So you see the radius, that radius you will be writing in kilometer if it is in kilometer, and then that value and 10 raised to the power 3 meter, because 1 kilometer is 10 raised to the power 3 meter. And the value of G, the gravitational constant, the capital G, that is the radius R. The correct labeling is very important. If you remember the labeling, then your mass will be detected. So that is G. Oh, let me write G there. This is G. So the value of G you already now know. So I don't want to write it again. So which formula will be used? Of course, you just see, look, they want the gravitational acceleration. Find the acceleration due to gravity. So required. What is required from you? Acceleration due to gravity. Due to gravity. That is required, means this G is required. So you see, solution is, we know that what we know, that m is equal to what? M is equal to G R square, G R square into G. That is the standard. That is what this formula is, a standard formula, you see. So what we actually need, uh, we need what? We need this G. So of course this G is directly arrow this one. Instantly, if you remember this by heart, very good. Gm into R square. So you have all the values. It is the, this is known to you, this is known to you, and this is known to you. So you can easily find this one. You solve it and then discuss with me. Okay, that's how you do it. Okay, the next one. Now this is just, I did not include any formula in this thing. The acceleration due to gravity on the surface of the moon is here in the list of the given. If you just find your given here, given. So what are your givens? In the givens, you have the acceleration due to the gravity. So acceleration due to, yeah, the acceleration due to gravity. Okay, this acceleration due to gravity G, but it is on the moon, not on the earth. Remember, G on the moon. So you can label small g on moon. and that is 1.62 meter per second square. Now the radius of the moon is this one, radius. The radius of the moon, it is r, and this radius of the moon is 1740 kilometer. So as I told you, now this is the unit consistency checking. Here you see the units are in what? Here you see the units are in meter per second square. That is in case here it is what? It is the multiple unit of the meter. So look, this need to be changed. Clear? So what I'll be writing, 1740 into 10 power 3 meter. So to make to make it even prettier, what I'll be writing, 1.7. This is just like 1.74 into 10 power 3 into 10 power 3, like that meter. So better to write 1.74 into 10 power 6 meter. Later on, uh, uh, after practicing many times, you will be able to do it very quickly. Now for it, I did it for you. If I was supposed to do it myself, I wouldn't write like this instantly, that when I see this thing, how I would like. Look, I'll be quickly writing 1.7 into 10 power 6 meter. 746 meter. I'll be quickly writing like this. So inshallah, once you practice it, then you will learn it. Now find the mass of the moon. So they ask for what? For the mass of the moon. Okay, that is mass of the moon. Now, if you remember this thing, the mass of the moon. Now, look, I don't have the formula sheet, for example, in front of me. So quickly, A's, I'll be, I know that A's G is equal to what? Gm by r square. So what is the mass of the moon? The mass of the moon will be gr square divided by gr square divided by this g, right? So you have all the values, and the answer will be in kilogram, because mass is measured in kilogram. It is the logical solution. Checking now the next one. If you look, see the 5.5, calculate the value of g at the height of 3600 kilometer above the surface of the earth. Find the value of g due to the earth at due to the earth at geostationary satellite. No, find the value of g at that point due to the geostationary, for the geostationary satellite. There might be difference in the wording of the problem, right? Now you know that the height is given. Here, look, you will be writing given or like that. Now I'm not writing it again and again because of the time. So you see, look, what is the height is given? Given. In the given, the height is 3600 kilometer. Now, as I told you that you can do it as quickly like this, 3.6 into 10 to the power 6 meter. Okay, the technique I told how we can do it. This is the height. The radius, look, the radius of the earth is not given. That is hidden variable, right? The radius of the earth r, and that radius is 6.4 into 10 power 6 meter, right? And find the value of g at that altitude. What they even the gravitational constant is also not given. Gravitational constant, if it is needed in our calculation, the gravitational constant, okay, that is g, and it is 6.673 into 10 raised to the power minus 11 newton meter square per kg square, like this. So the gravitational constant is this one. Now when you are solving this thing, the required is what? For this, find the value of g at that height h. The value of g at that height h. So gh is required. Now what will be, which formula will be used? Of course, in our solution is we know that g at height h will be equal to what? It will be equal to g m into what? R plus h whole square. So the important point here is this one, that that is this combine this value, which that is this value, the value, this value, the r plus h combined. This is the radius of the orbital radius, the radius of the orbit, radius of the orbit. This radius of the orbit, it is the sum of the radius of the earth plus that height. So you must be very careful while reading your problem. That look for, that is calculate the value of g at the height 3600 kilometer above the surface of the earth. It means that the height is given in the radius you will add. Sometime if they tells you, for example, there might be look the same numerical, thanks God this numerical is here. Find the value of g due to the geostationary satellite, the radius of the geostationary orbit. Here look at this thing, radius of the geostationary orbit. Here they do not say that above the surface of the earth. So this is combined r plus h, directly it is given, and that is 48700 kilometer, or you can say 487, and this is 4 and that is 3, so 10 raised to the power 7 meter. So you will just write like this, r plus h, and radius, orbital radius bus, orbital radius, yeah, radius of the orbit, right? So you must be very careful about these points. If they say from the surface of the earth, yeah, above the surface of the earth, or if they say the orbit, the satellite orbit, the whole orbit, then you need to understand this thing. Now simply use gm at the value of this, the value of this, use calculator and find your answer and express your answer here in meter per second square, and then tell me that whether your answer are matching with the book or whether they're logically correct. Now look, so they say find the value of g again due to the geostationary satellite. So for this, you use gh into gm into r plus h whole square. Clear? So you see you have all this thing, the r plus it is given, this is given, this is given, like that. So again the answer will be meter per second square, right? Look, so how are they easy? The value of g is 4 meter per second square at a distance of 10,000 kilometer from the center of the earth. So if you just look at this problem here, the center from, look what is mentioned, from the center of the earth. So what does this means from the center of the earth? Radius of the orbit, radius of the orbit, yeah, orbital radius. Again this is r plus h, in this r plus h is what, 10,000 kilometer. So 10,000 kilometer, 10,000 kilometer, or you can say that is 3 and that is 4, so 1 into 10 is to the power 7 meter. And they say find the mass of the earth. So definitely look which formula will be used is, you see, we will be using which formula? Look, mass of the earth is required, so g, the value of g at that height, h is given. So you see g at that height, and look here it is multiplied, here it is divided, there will be multiplied r plus h whole square and divided by g, and it is your m, mass, right? And the answer will be definitely in kilogram. Clear? 5.8, that at what altitude the value of g, okay. Now look here, at what altitude the value of g would become 1/4 then on the surface of the earth. Okay, so look at what altitude. So the value of g would become 1/4. The value of g would become, so g at that height h, it is given g into that is 1/4 of the value of g on the earth. So they says that find that altitude, that height. So if you just see, look at this problem. As we know that this GH is equal to what? It is equal to GM into what? Into R plus H whole square. Now, class, you know that I just want to tell you a very simple formula for solving this thing without using any numerics. You see, look, as we know that this small g is equal to what? G m into r square, the radius of the earth. Right? This is we are doing for the earth, so I'll be putting for the earth all these things. So mass of the earth, the value g on the earth in this one. So you see, look here, I just make transformation. You see like this, g into me. So look, see here, if I use this equation right there, so what it will be look like this one. You see, this will be g on earth into what? Into re square into what? Into re plus radius of the earth into h square. Now, if you see, look here, this the value of g on the earth, it is equal to what? G4. It is given to me. This is g re square like this, and this is what? R. This is re plus h whole square. You see, look at this. This will get cancelled with this, and if you make your calculation more easy, look, this will be equal to re plus h whole square. Look, this is this and this is this, and this will become equal to what? 4 into re square. Further, if you simplify this, re plus h whole square, and this is 2 re whole square. And you see the square get cancelled, and then what will happen? That re plus h will be equal to re. This means that your h is equal to 2re minus re. So what does this mean? That I didn't understand that. H is equal to re, which is equal to 1 earth radius. So if you take the satellite, if the height equals to 1 earth radius, the value of g will become 1/4 or 1/4. Now this is one way of solution. Another one, if you use a numerical approach, look how we can use a numerical approach. See, look at this. I just want to use a numerical approach. Look, you have the value of g, so put the value of g like what? 6.67 into 10 raised to the power minus 11 Newton meter square per kg square. The mass of the earth, you know that it is 6 into 10 raised to the power 24 kg. The height you are going to find like in your formula. Okay, it will go there and this will come here. The value of gh, it is 1. It is 1/4 of the value of 1/4 of the value of g on earth, 10 meter per second square. So it is this. Right now you can use these value, and how to calculate this h directly. This formula, let me show you in a formula list like this one. As I have solved for height h also in this formula, you just see, look for the height somewhere here. For the height, this formula for the height is equal to gm gh minus r. That is gm under the root Look, uh, which formula we will be using? This one. It will be, see here. Look, this one. Okay, so which formula then? Construct a formula that will be it will be equal to what? G, it will be equal to Gm E by Gh, like this. And then the square root and minus Re, and that will came out to be your height, and this will be the substandard formula for the answer directly. So this is how when you use numericals values, and this is how when you use expressions. So I usually like using expressions, right? A polar satellite is launched at what? Is launched at a height 8 kilometer above the earth's surface. So you see again, like here, which thing is given? 850 kilometers. So again, this is that r, small r, and this is what we call the radius of the orbit, rh, and it is how much? 850 kilometer. So this is what? 850 into 10 raised to the power 3 meter, right? And this is the orbital speed. So V orbital is equal to what? You remember it was in your last time you derived it to you that G, a polar satellite is launched at the, okay, it is a gh into r. But remember here, for to find the value of gh, you need to do which thing? The g mass of the earth into r plus h, you need to do it again. So that is a very long way to go. So we have, as I told you, that sometime you will have many formulas in solving the given numerical. So you should always go for the easier approach. Now this approach is difficult. Why? Because you need to calculate the value of GH first. So what I will do, very simple. I will be using this formula. That it is GM into what? Into R plus H under the row, like this. This is very easy formula. And where this formula comes from, I did not do any special things, but I just use this expression, right? Because look, let me do it for you also here. Is see, look how I can just look, where does this formula comes from? You see, look at this thing here, this V naught is, you see, GH. What is the value of GH? It is GM, you see, into R plus H whole square. And here you have what? You have this as R, what? This R is equal to R plus H. You see, so this one R plus H, this get cancelled with this thing, and what is left with you? V naught equals what? GM into R plus H. So better to use this direct formula while solving the given solution. Now number 10, numerical. A communication satellite is launched at 42,000 kilometers above the Earth. Find its um, orbital speed. So here the same is above, but in this case the radius of the orbit RH is equal to 42,000 kilometers here, and that is what? That is launched, that is the Apollo satellite is launched above the earth. Okay, so that is what you need to include the radius. In this case you have the height h given 850 kilometer. I'm sorry for this. 850 into 10 power 3 meter. And the radius of the orbit, you always know, that is 6.4 into 10 raised to the power 3 meter, right? So here, because they use the word above the earth, so the orbital radius is not given. In this case, what is there in this numerical? In this numerical, this thing is directly given. This one, which is what? That is R plus H, the radius of the orbit, R naught, or that R in your book. It is what? It is equal. it is equal to r plus h is equal to what, 42,000 10 to the power 3 meter. Okay, so use that simple formula. This is the, and if you have any queries about this, you can ask me on Zoom. Hope you understand the today lecture. Thank you very much. Now your home assignment is that you solve all these numericals in your notebook, and you know I did not put the values deliberately, so I left it for you. You put the values, use your calculator and find the answers. Okay, so find the answer. So this is our today lecture. Hope you understand a lot from our today lecture. So thank you very much and see you next time.